Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update for February 1st of 2023. Winter has definitely arrived in the Yellowstone region, and in fact this area is known for really harsh winter conditions that go back thousands of years. During the last ice age, Yellowstone was actually home to one of the thickest ice sheets in the continental United States. There we saw ice that was over half a mile thick that only started melting out around 14,000 years ago or so. And of course those harsh winters have continued today because the Rocky Mountains in that area are the highest elevation anywhere in that range on average. There's also a lot of precipitation that's focused into that area due to the topography. So we get a lot of snow, a lot of ice, very cold conditions, negative 40 degrees Fahrenheit in places in the interior of the park. That's harsh for animals, that's harsh for humans, that's harsh for volcano monitoring equipment as well. But we've taken specific steps to try to engineer the monitoring equipment against these harsh winter conditions. For example, seismometers are mostly buried. So that keeps the seismometers more or less immune to these snowy and icy conditions. And the solar panels and the radio antennas that push the data out are at very high levels above the ground to prevent them getting covered in snow. Same is true with GPS equipment. The challenge with GPS, though, is that sometimes the antennas can get covered in ice during conditions that are really, really stormy. And that can cause the signal to take a little bit longer to get to the antenna, and that makes it actually look like the ground might be deforming when in fact it's just ice on the antenna. And we've got a couple examples of that right here. This is the GPS data set from a GPS site near the Norris Geyser Basin. So this is vertical deformation. Each one of these blue dots is 1 day worth of data. And you can see this significant deviation where it looks like the ground went down and then popped right up again in December of 2021, and again a couple more times in November of 2022. These time periods corresponded to really intense winter storms in the Yellowstone region that caused the antennas to ice over and thus make it look like the ground was actually moving. But that was just ice on the antenna. When the ice went away, we pop back up to where we were before. And we can see this sort of effect to varying degrees throughout the region. But fortunately, it's something that's recovered rather quickly, and because we have so many GPS stations in the region, over 30 in the old Yellowstone area, we can use the data from different sites to make sure that nothing actually is moving. This is a weather sort of phenomena that we're seeing. That, plus the seismic data, which is always flowing, allows us to really get an idea, even in the harshest kinds of conditions, the dead of winter in Yellowstone, of what's happening beneath the ground surface. So that's a bit of how we mitigate against these sorts of effects that we see in Yellowstone, even though sometimes the GPS data, we can actually see these big winter storms. Well, now let's talk about what happened over the last month in the Yellowstone region in terms of seismic activity, ground deformation, and also geysers.
During the month of January, activity in the Yellowstone region remained at normal background levels. The University of Utah Seismograph stations, which is responsible for the operation and maintenance of the Yellowstone seismic network, located just 75 earthquakes during the month. The largest was a magnitude 2.5 that occurred on January 5th, right at the southern boundary of Yellowstone National Park. This was part of a small swarm of 11 earthquakes that were located in the region over the course of a 2-day period. There were also an additional 28 earthquakes that occurred in this area that's sort of near Norris Geyser Basin between Norris and Mammoth Hot Springs. This has been an ongoing area of seismicity for the past many months, since at least last summer. 28 new earthquakes were added to the sequence that's been ongoing in this area. But otherwise, activity distributed throughout the region, as it often is, with most of the seismicity occurring in this belt between Hebgen Lake and north central Yellowstone National Park. This is the hotbed of seismicity for the region historically. Turning now to deformation, this is vertical deformation, up and down motion, at the White Lake GPS station on the east side of the caldera. Each one of these blue circles represents 1 day of data, and this time series goes back 2 years. Downward trends indicate subsidence, and upward trends indicate uplift. And the overall trend during this time period, of course, is the subsidence that has been ongoing since 2015. It's interrupted during the summer months by a pause in the subsidence or even a slight amount of uplift. And that's caused by runoff from snowmelt that sort of puffs up the ground as the ground soaks up that water like a sponge. But the overall trend is of about 2 to 3 centimeters per year of subsidence. That's about an inch per year of subsidence. And you can see after the end of summer 2022 that continued. There are a number of little offsets here in the winter time, and that's caused by snow and ice accumulation on the antenna, which disrupts the GPS signal a bit. If we move over to the western side of the caldera and the Mallard Lake Resurgent Dome, this is a GPS site near Old Faithful, and that same overall trend is apparent. Subsidence of about 2 to 3 centimeters, about an inch or so per year, interrupted during the summer months by a small amount of uplift or a pause in that subsidence with, of course, the winter storms. At Norris Geyser Basin, we haven't seen much in the way of any deformation, up or down motion over the past several months. This is the 2-year plot at Norris. There's the summer uplift, lots of winter storms that are manifested as small amounts of subsidence, but then really nothing since the end of the past summer at the Norris area. That's remained steady. And finally, looking at Steamboat Geyser, everybody's favorite geyser, the tallest geyser in the world. This is the temperature record in the geyser outflow. We started January with a lot of minor geyser activity. That's a lot of this up and down motion here, with a major eruption that occurred on January 5th, and then the temperature went back down to air temperature, of course, right around freezing. We saw minor activity pick up in mid-January, culminating with a major eruption here on January 28th, and then back down to air temperature readings as the geyser stopped even having little minor eruptions. So 2 eruptions to start the year with Steamboat. I guess that means it's not quite done yet, putting on a show for visitors to Yellowstone National Park.
Well, that does it for the monthly update for February 1st of 2023. Remember, if you have any questions at all, you can feel free to email us anytime at yvowebteam, all one word, at usgs.gov. Stay safe, stay healthy, stay warm, and we'll see you next time. Bye-bye.